Good evening, everyone. My name is Takiwa Smith, founder and executive director of Science, Engineering, and Mathematics Link Incorporated, and I want to welcome you to our Math and Science Career Academy's Teen Science Cafe. The Teen Science Cafe is a program of our Math and Science Career Academy whose goal is to expose youth to STEM and STEM careers. The Teen Science Cafe is focused on teens because of the time within their K through 12 experiences where they are making decisions about college and career. So middle schoolers are making decisions about what high school they will go to and if they want to attend a magnet school, what extracurricular activities they may want to participate to explore their interest in STEM. And high school students are making decisions about what they will major in college, what college they will attend. All these decisions are really important decisions. And when it comes to STEM careers, it is really helpful for them to have someone that is a positive adult role model in STEM that they can talk to and learn about their journey and learn about the various possibilities for pursuing a STEM career and the options that are available to them. So without further ado, I'm going to turn it over to our program coordinator, Carlin Pounders, that is going to introduce tonight's speaker.
Thank you, Tequila. Hi, everyone. So thank you for joining us. Uh, this month, we decided to focus on neuroscience and aspects of the brain and how it's studied in STEM. And so we're very excited to do what is almost like a part two to our first cafe that we had this month, where we talked about moods. And now we're going to be talking about memory. And I'm sure a lot of you are probably familiar with concussions and how those can happen, particularly in sports. So we have a speaker tonight who is very informed on all those topics. Kyndall Nicholas graduated from Hampton University in Hampton, Virginia in May 2019, where she majored in biochemistry and minored in psychology while playing Division I volleyball. As an undergraduate, she had the opportunity to conduct neuroscience research in the NYU Summer Undergraduate Research Program in the summer of 2017 with Dr. Callie O'Reilly and Dr. Andre Fenton's lab. During this summer, she conducted behavioral testing where she studied the prefrontal cortex and spatial working memory. After graduation, she became a postbac scholar in the NIH-funded postbac research education program at Johns Hopkins University, where she studied gene expression in the prefrontal cortex in Dr. Carrie Martinowicz's lab. She is now a PhD student at the University of Pennsylvania in the neuroscience program studying concussions and diet. When she is not in the laboratory, Kendall enjoys working out, cooking, and reading. Those are all great things. So without further ado, I will hand it over to Kendall.
Hello, everybody. I'm so pleased to be here, and I'm just so excited to talk to y'all. So, if you have any questions about anything, do not be afraid to ask, and we can hop into my presentation. All right. All right. So, let's get into it. So, first, as you probably know, this was titled How Psychology and Athletics Created a Neuroscientist. And that sounds bizarre. So I'm going to tell you a little bit about it. So, first, I'm Kyndall Nicholas. Who am I? So, as already stated, I graduated from Hampton University. And Hampton University is a historically Black college. It's located in Southern Virginia. And you can see I'm holding a volleyball here. I'll talk a little bit more about that. I was born and raised in Maryland. So this is me eating Mexican food, which is like my favorite food ever in Maryland. And then now I'm a PhD neuroscience student at University of Pennsylvania. And this is that picture. And I'll talk a little bit more about what a PhD is and also what neuroscience is as a whole and what it means for me. So how did I get into neuroscience? Well, there is this program that I did in high school called IB, or International Baccalaureate. And so you have to, it's very rigorous. You have to study a lot of different things, but you get to pick a subject that you want to study. So I chose psychology. And so this right here is a picture of my psychology textbook. And you can't see from the picture, but it is extremely thick. And so you have to learn literally everything about the brain, psychology, how you think, what motivates people, how people work together. And so there's one section of this book, I remember it was chapter 3, where we had to study the science of the brain. It was so hard to me. And I had to stay up every night for like 3 weeks straight to basically try to pass. And then I did pass. And this is me giving my speech, a valedictorian speech at high school. And so the reason I put this here is because even though neuroscience was the hardest part of the IB psychology part class, I passed it and realized I loved that stuff. So when they introduced me for my speech, they said, Kendall wants to pursue neuroscience in graduate school. And so IB psychology really was the beginning of how I started thinking about how other people think, or what motivates them. And so then, as stated before, I got to play volleyball to go to college, and they paid for my college, which was nice. And so here's a picture of me playing volleyball. But here is a picture on the right of me and my team discussing things. So we're not cheering. So this picture is us trying to figure out how to get the next point, because we did not get that point. And so we were trying to figure out, how do we win? How can we win? We're all discussing different game plans, and we didn't have the same plan. So this is the beginning where I started thinking about team dynamics. We all had the same goal, but we all thought differently. And this really started to make me think and build on what I learned from my IB psychology, of how people, continuing to dig deeper into how people think and what motivates people, because we all had the same motivation to win. So then, continuing to play volleyball, to describe this picture a little bit. And if you don't know a little bit about volleyball, so this is me, and I'm trying to block this ball that she's hitting. So this block is fine. My head is below the net. But sometimes when I jumped too high, my head would go above the net and the ball would go straight into my face. And one day the ball went straight into my face and it hit me hard enough to knock me down to the ground. It was super hard for me to get up. The lights were bright, people talking, and the noises were hurting my head. And I got diagnosed with a concussion, which we'll get a little bit more into later. But I got diagnosed with a concussion. And so I was out for about a week, but then I was able to play again. But then my friend, who played for the same school, who played football, also got a concussion. And he was out for about 2 weeks. And then when he started going back to playing, he kept getting headaches. He started feeling like he couldn't remember his schoolwork. And his memory was hard. It was hard for him to learn. It was hard for him to pay attention. And he actually had to go back to the hospital for medicine for his migraines. And so although he had was cleared to play again, he wasn't done being affected by his concussion and got diagnosed with something called post-concussion syndrome, which I would describe a little bit more later as well. And so seeing that I got a concussion and he got a concussion around the same time, but they affected us differently, really made me want to look into what made this happen. Why was it this way? How could we experience essentially the same thing and have different experiences? So I went into NYU, as stated earlier, to study learning and memory for their research program. And it was an amazing, transformative experience. I wanted to study learning and memory because, as I stated before, concussions affected my friends' learning and memory, where I was fine. So what I wanted to know a little bit more about, like, what made that happen. So this is me in 2017. So that's like 4 years ago now, where I really got to do science for the first time that wasn't in class. And that was odd, but I loved it. I realized that I wanted to continue to do this. So this is me looking through a microscope that's fancy for the first time. And this is me doing holding something called a pipette and messing with DNA. But not only was this experience transformative because I got to do science for the first time, I got to hang out with neuroscientists as well. Hampton University did not have a neuroscience program, so I didn't know how they thought, other neuroscientists thought. I didn't know what it was like to be in a social setting, but this program allowed me to hang out with them. We went on a hike, we rode a train, and it was just really nice. And then at the end, which is a huge part of science and what I'm doing with you today, I got to present this science. So this is me presenting my science on the learning and memory. And this is us at a dinner at the end of the internship. So I was like, okay, I've played sports. I learned learning and memory is different. I got to, have an experience with this, but I was not 100% sure that I wanted to continue to study learning and memory just yet because I didn't know that much about neuroscience outside of this experience. But I wanted to continue neuroscience. So then, after I graduated, I went to Johns Hopkins and I studied mental health disorders. So, mental health disorders are not only affecting your mood, but those states can also affect your learning and memory. So, it was kind of like another bridge to the learning and memory from the concussion. Also, concussions can affect your mental health. So, this is the Lieber Institute for Brain Development at Johns Hopkins. And this is me holding a brain that I dissected myself. And here's a little picture that gets a little closer on the brain. And as you can see, the brain is super soft. Another word for soft that we use is malleable. So which basically means that it can be moved and shaped differently sometimes, which is not always the best thing when it comes to concussions. And we'll talk about that more as well. But I was like, I love this. Again, didn't know if I wanted it to be learning and memory. Didn't know if I wanted it to be mental health disorders. Was completely unsure what I wanted to study. But I knew that I wanted to keep studying neuroscience. And so I actually took a class at Johns Hopkins that helped me learn a little bit more. And I wanted to know how the brain communicated because essentially learning, memory, and mental health is all your brain communicating. So we can dive into that a little bit deeper now. So your brain is made up of neurons, and neurons are brain cells, essentially. So the basic breakdown of it is that there is a cell body, also called the soma, which is this orange bubble here. And so as you can see, there's different things in there called organelles, which basically these organelles help to maintain the function of these cells. So they help bring energy or maybe break down something. They have many different jobs in the neurons. And there's actually many different types of neurons with different jobs. You have these dendrite branches, which help to receive a message that may come from another neuron. You have this bridge, which is called an axon, and that helps the message travel. And these yellow things are myelin, which basically helps the message travel faster. So the more myelin, the faster the message is communicated between the neurons. And then you have a synapse, which releases the message to the next neuron. Your brain is made up of tons and tons of neurons. Each brain is actually different, though. And so this is a closer picture on how they communicate. So this would be the synapse of what we saw before. And these yellow things can be seen as neurotransmitters or the message that is being sent throughout the neurons and how the brain is communicating. So I was like, this is absolutely amazing. I wonder what role this plays in literally everything. So I didn't know what role I wanted to have in neuroscience because there are a ton of jobs with neuroscience. And so, of course, as one that I am doing right now, you can be a scientist, you can research a little bit more. But there's other jobs. I love sports, I love games. And so one of the things I could do is be a game researcher, which literally they spend their time trying to figure out how to keep you trapped on the games, why you love the game so much. So if you're like, oh my gosh, I love this game or this game is addictive, most likely there's a neuroscientist behind that. Another thing is a mental health professional. I talked a little bit about how mental health played a role, how I was studying mental health. And so I could literally go into mental health, the field, and maybe be a psychologist for someone or just teaching about mental health. And the other job that was interesting to me was marketing. This may seem really weird because this is about money, but there is this field called neuromarketing. And so you can see this as ESPN, CBS, Pepsi, PepsiCo, eBay, all people, even Google, they have neuroscientists behind them to try to keep you on their websites, keep buying their stuff, and keep giving them money. And while I'm not a money hungry person, I thought it would be really cool if you can figure out how people think and figure out how people remember stuff and how they want to buy your things. I just thought that was amazing. But I was still unsure. Basically, I went to study for my PhD in neuroscience at University of Pennsylvania last year, so I'm still here. So a PhD is a 5-year program where you get paid to do research, and when you make a groundbreaking research or discovery, you publish it, and then you're able to get your PhD, which is after college. And so this is me at the University of Pennsylvania, and here is my PIN card. So I told you about how I started off just being interested in psychology, and then how I was interested in learning and memory. Then it turned into mental health disorders, and I wasn't sure what job I wanted. But I was really thinking about, what did I really want to research? Because like I said, you have to research something to fully get your PhD. And I remembered that concussions connected to all of these things. So I decided to continue to study a concussion. So I've talked a little bit about concussions, but I haven't told you what one is. So we're going to watch a video to discuss exactly what is a concussion.
Each year in the United States, players of sports and recreational activities receive between 2.5 and 4 million concussions. How dangerous are all those concussions? The answer is complicated and lies in how the brain responds when something strikes it. The brain is made of soft, fatty tissue with a consistency something like jello. Inside its protective membranes and the skull's hard casing, this delicate organ is usually well shielded. But a sudden jolt can make the brain shift and bump against the skull's hard interior. And unlike jello, the brain's tissue isn't uniform. It's made of a vast network of 90 billion neurons, which relay signals through their long axons to communicate throughout the brain and control our bodies. This spindly structure makes them very fragile, so that when impacted, neurons will stretch and even tear. That not only disrupts their ability to communicate, but as destroyed axons begin to degenerate, they also release toxins, causing the death of other neurons too. This combination of events causes a concussion. The damage can manifest in many different ways, including blackout, headache, blurry vision, balance problems, altered mood and behavior, problems with memory, thinking, and sleeping, and the onset of anxiety and depression. Every brain is different, which explains why people's experiences of concussions vary so widely. Luckily, the majority of concussions fully heal and symptoms disappear within a matter of days or weeks. Lots of rest and a gradual return to activity allows the brain to heal itself. On the subject of rest, many people have heard that you're not supposed to sleep shortly after receiving a concussion because you might slip into a coma. That's a myth. So long as doctors aren't concerned there may also be a more severe brain injury, like a brain bleed, there's no documented problem with going to sleep after a concussion. Sometimes, victims of concussion can experience something called post-concussion syndrome, or PCS. People with PCS may experience constant headaches, learning difficulties, and behavioral symptoms that even affect their personal relationships for months or years after the injury. Trying to play through a concussion, even for only a few minutes, or returning to sports too soon after a concussion, makes it more likely to develop PCS. In some cases, a concussion can be hard to diagnose because the symptoms unfold slowly over time. That's often true of subconcussive impacts, which result from lower impact jolts to the head than those that cause concussions. This category of injury doesn't cause noticeable symptoms right away, but can lead to severe degenerative brain diseases over time, if it happens repeatedly. Take soccer players, who are known for repeatedly heading soccer balls. Using a technique called diffusion tensor imaging, we're beginning to find out what effect that has on the brain. This method allows scientists to find large axon bundles and see how milder blows might alter them structurally. In 2013, researchers using this technique discovered that athletes who had headed the ball the most, about 1,800 times a year, had damaged the structural integrity of their axon bundles. The damage was similar to how a rope will fail when the individual fibers start to fray. Those players also performed worse on short-term memory tests. So even though no one suffered full-blown concussions, these subconcussive hits added up to measurable damage over time. In fact, researchers know that an overload of subconcussive hits is linked to a degenerative brain disease known as chronic traumatic encephalopathy, or CTE. People with CTE suffer from changes in their mood and behavior that begin appearing in their 30s or 40s, followed by problems with thinking and memory that can, in some cases, even result in dementia. The culprit is a protein called tau. Usually, tau proteins support tiny tubes inside our axons, called microtubules. It's thought that repeated subconcussive hits damage the microtubules, causing the tau proteins to dislodge and clump together. The clumps disrupt transport and communication along the neuron and drive the breakdown of connections within the brain. Once the tau proteins start clumping together, they cause more clumps to form and continue to spread throughout the brain even after head impacts have stopped. The data show that at least among football players, between 50 and 80% of concussions go unreported and untreated. Sometimes that's because it's hard to tell a concussion has occurred in the first place. But it's also often due to pressure or a desire to keep going despite the fact that something's wrong. This doesn't just undermine recovery, it's also dangerous. Our brains aren't invincible. They still need us to shield them from harm and help them undo damage once it's been done.
All right. Awesome. So, as the video said, concussions are different for everyone. And so one of the symptoms that they didn't list was audio processing. And so my friend that I described earlier, he could hear fine, but he would get headaches and migraines. I didn't get headaches and migraines, but when I was hearing, it was terrible. Like I was on the phone with my mother and I was like, you're hurting my ears. So we're going to hear a little bit of like how I was when I had my concussion while trying to have to complete a task. And so this task under normal circumstances is like somewhat easy. But I had to do it with where every time someone talked, it was also annoying and hurting my head. So I'm going to give you a little warning that you might want to turn down your computers just a little bit. I don't know how loud your computers are, but I don't want it to be too annoying or too painful for you. And you're going to have to try to complete this task while hearing what I heard. So I'll give you 5 seconds to turn it down. All right, so try to complete the task in this video.
This is a test of selective attention. Count how many times the players wearing white pass the basketball. How many passes did you count? The correct answer is 15 passes. But did you see the gorilla?
So there's two things that could have happened there. You may have not been affected by the noise at all, and that's good for you. You may have been able to count the 15 passes, but you might have not seen the gorilla. If that is the case, then you were able to function as expected and focus as expected, and you have great focus. The other thing that may have happened is you weren't able to count and you may have not noticed the gorilla. Then that noise definitely threw you off, and that's one way of having concussion. And the third response could have been that you weren't able to count and you noticed the gorilla. And so what that means is you weren't actually able to pay attention to the passing and counting task, and you were just switching your attention everywhere. And that's what it felt like for me having a concussion, and what it feels like for many people to have a concussion, where it's hard for them to focus, their attention keeps shifting everywhere. And that's what makes it so hard to continue to learn and then try to remember. Because the fourth response could have been you were counting, but then you saw the gorilla, but then you kept trying to count, but you couldn't exactly remember how many passes it was at, or what number you were at. And that's really a lot of the different responses of what it's like to have a concussion. All of these could have happened. None of those could have happened. But that's what makes studying a concussion so complex and trying to remember while having a concussion. So adding on to the learning and the memory, the mental health disorders, the thinking, the different audio processing, and like in the video said, sometimes people have blurred vision. All these different things are a part of concussion. So I wanted to figure out, what could I study that connected a concussion, but was relevant to literally everyone. And so, so one of the things are, when you get a concussion, while a student athlete, there's this organization called the NCAA. And the NCAA has a protocol that they basically tell you what you can and cannot do, and what you need to do before you can start playing again. And one of the things are, there are foods recommended to us after we get a concussion that we should not eat and that we should avoid. So that's dairy products, anything with butter, cream, milk, cheese. So this includes ice cream, any type of dessert, fatty meats such as steak, lamb, also fried chicken, anything fried like that has a lot of fats in the oils. Processed meat, so deli meat you can't eat, and sugary drinks, and because the sugar is not good. And so this is what's told to us to avoid, because it's not good for the recovery of our brain. And if you remember from the video, that those concussions start really messing up that axon, which is that bridge of helping the message travel through your neuron. But if you remember, there's this myelin that's made of fat that protects the axon. And so the more myelin, the faster the message. Well, that myelin is made of fat and cholesterol and other different things that we get from our food. So we're told to avoid these foods after a concussion. But we don't know, if you have a concussion, what to avoid. We don't know what to eat before and how that can help our recovery or how it can affect the concussion. And so if we're not supposed to eat fat after our concussion, but fat helps our axons transmit the message, then is there something that we can eat before to make it better before we get the concussion? So this is basically the question that I'm trying to ask. So I have to essentially try to understand what type of fats make up the brain, and what fats are affected when you have a concussion like this. And so I'm only 1 year in, so there is a lot of work to be done, but this is how I got my psychology, understanding how people think, learn, remember, into understanding how a team works, what motivates people, how to keep people going, and then how someone who has a concussion that's different than mine, and equaling a neuroscientist, which is me, and my question. And so one of the main things that I want to focus on from this question is that not only does our food affect our brain, but how they communicate equals our memory and our learning. So the faster a message is communicating, the faster you can learn something and the faster you can remember something. But if that fats are broken down around the axon, you won't be able to learn anything. So this is what I'm working on. I hope that y'all were able to learn a lot. And if you have any questions, please ask them. You can ask me questions about concussions. You can ask me questions about food in the brain. You can ask me questions about mental health disorders, learning and memory in more detail outside of concussions. You can literally ask anything, but I hope that you enjoyed this. Oh, you're muted.
Okay. So I did have a question as far as you even ended with taking IB psychology in school. What advice would you give to teens as far as seeking out, whether it be classes or extracurricular activities in, neuroscience or any other STEM area that they're interested in?
Yes. So one of the main things that I tried to highlight a little bit is that science is everywhere. It could literally connects to everything. So when taking classes, try to figure out what is like if you're trying to figure out the science to it, what is that link? So for me, the psychology is like someone just thinking, right? Talking. But there's literal science behind my voice. Some people may study my like the literal sound of my voice. Some people may study like what I'm thinking before I speak. So that's something simple. So if you're like taking Spanish class and you're like, how do people process language? That could be a question. How do people remember different languages? You have some people who can remember 7 languages, and meanwhile, I'm still struggling on the vocabulary in English that is my first language. So my advice is when you're taking a class, try to figure out what that link could be and what greater question could that connect to, especially within science, because literally there's a science behind everything. And I promise you that. And playing volleyball, some people study how it's best to move our bodies so that we can be better volleyball players. And that's like the study of the movement for us. But I'm interested in the study of what happens to our brains when we're playing. So there's literally something behind everything. And just remember that all your classes are literally related, and they're just hold on to those things that you're like really diving deep into. Because like I said earlier, I was really stumped by the neuroscience part of my IB psychology. And then I was like, why do I care so much? Normally you're just like studying because you're trying to get a good grade. Okay, cool. But I was staying up later than I really needed to because I was like, oh, this is cool, even though it was like the hardest section. And so that's what I held on to help me, keep going and pursue my career that I'm in now.
That's a great point, because a lot of times, we kind of touch on the fact that there's this idea that STEM is hard and challenging, but as long as you're, one, passionate and interested enough in the subject, then you can just keep studying it and almost like persevere to get to, where you need to get to, whether it be, a good grade or into a program that you're applying to, or, a college that you want to attend, anything like that.
Yes, exactly that.
I also wanted to ask, as far as balancing, given what I just said about how challenging and probably time consuming with the amount of studying that is necessary in reading and research. The balance aspect of being an athlete, but also pursuing this STEM pathway. Can you talk about that?
Yes. The balance was probably the hardest part. And honestly, I had a great old planner, a trusty planner that I always wrote in. That's really what kept me on top of things. But what I did is while traveling to the games, I'm working and studying and reading. So I'm on the bus, not just sleeping, I'm working, reading, and studying so that when I get to wherever I am sleeping, I can actually go to sleep and not have to worry about working. And then vice versa, I would like while I'm at the game and I'm just waiting on my pregame, sometimes I'll read a little bit. But then I also had to remember I'm here for my game. So sometimes I'll put the work away and just focus on where I'm at for the moment. And that's trying to, play really well and focus on my like success in the game and what I'm going to contribute to my team. And I think also just being interested in team dynamics for me and how I think, I started talking to my teammates a lot more and figuring out what motivated them, because I saw myself as like the little team psychologist that would like try to motivate people the way that they felt needed and what kept them going. And that kind of helped me in the way of, okay, I'm not able to read my scientific papers. I'm not able to like connect the brain and do all these different things, but I'm putting into work, into practice with me, which is how people think, how people are motivated. So that was like my little way of having a practicum or like practical action of what I love to do. And that's kind of how I felt balanced in all of these different things, because I'm still putting into action what I love that's outside of the game and also outside of reading. And so when it comes to balance, is really like everything you do had to be with intention. And even if it's resting isn't with intention, because I need to be rested up to do all the 10,000 things that I was doing. So that's really how I was able to balance, because I had my planner and I was intentional about how I was using my time, which is not always the easiest motivation, because we love to just sometimes want to kick back and chill. And that's also good too. I used to write in my planner, relax for 30 minutes, like, I had to make sure I
You have
kept that
to,
time.
yeah.
Yeah, so that was good. But that's really how I balance being a student athlete and doing STEM, because also STEM as an athlete is not one of the most like popular fields to go into. A lot of student athletes, at least in my college and in volleyball itself, they go into communications and journalism and different things like that. So I used to be I actually, for 3 years, I was the only STEM student on the team.
Get
Um,
out.
yes, everyone used to be like, we don't know about that. But then they would come to me and be like, can you help me on biology? So, yeah, that was an interesting experience, but it was also fun, because for me, I'm like, okay, this is a way for me to teach. This is a way for me to teach biology and teach science. So I really did enjoy that. But the balance is hard. But when you love it and when you really want to do it, you'll figure it out. But definitely do not burn yourself out where you're exhausted and don't want to do it anymore.
Yeah, those are all good points. Another question while watching the video, I believe it said that having a concussion affects short-term memory. And I was wondering if there was anything as far as, I was thinking, is it the part of the brain that is impacted, or if there's some specific reason why, there was the mention of the short-term memory, because, for those of us who may not be aware, or I'm pretty sure everyone knows that we have short-term memory and long-term memory. So is there anything to that?
Yes. So there are different parts of your brain that are really active in short term and other parts that are more active in long term. And so
Okay.
what really makes that difficult is that, you know, the video showed a soccer player heading a ball, and then you had a football player like running into each other. Those are two different types of concussions and two different types of parts of your brain. So if I'm running into someone, like boom, that's a total different impact than me trying to go after a ball. So that can automatically have a different impact, have a different effect on the same part of the brain, actually. And force is something that some people are studying with concussions. If there's a different force, what happens? But that's really what makes it so different for short-term or long-term memory, because that experiment was actually done with soccer players. And so the soccer players, where a lot of people don't think about it because it's just a part of their sport to, you know, head a soccer ball. People are like,
Right.
okay, that's fine. But another sport that people forget about is hockey. Hockey is very aggressive and they're running into each other. They're running into the side of the wall. Those are also concussions. Or you have boxing. People don't really think about boxing. And then a part of boxing is TKO. You want to knock them out, but that's literally a concussion. Like literally someone won because they gave someone else a concussion. So and that's, some people are studying boxers because when you're punching, this motion also involves your spine and your neck. So that's a different type of concussion than someone football running into someone, than someone trying to head it. It just gets real complicated with the sports and then the different parts of their brain. But what makes it also harder to study memory when it comes to short-term memory is that if you've been playing the sport for a long time, then your memory has developed differently. So if I have been playing the sport since I was 3, then as I'm growing up playing soccer, my memory is totally different than someone who was 3 and didn't play soccer at all and head has never had any impact. So it's complicated because you're saying, okay, their short-term memory is worse, but is their short-term memory worse because they've been playing soccer? Or like, what does this mean for us, right? So this is a lot of different things that people are trying to study with memory. And I was like, this is just a lot of complications. So I'm just going to study something that connects to all of us, which is literally what we eat, because we all got to eat. We can't get through life without eating. So that's kind of why I chose the diet path, because I could dive into a sport. I could dive into the different types of forces and the physics and all these different things that come with that. But I definitely feel like eating and fats and cholesterol, and I don't like, it's interesting because you don't want to have high cholesterol, right? But
Right.
cholesterol literally is a part of what makes our brain so protected. So it's a huge portion of the human brain. It gets real complicated, but yes, it's a journey. But when it comes to short-term memory, there's so many different factors that come into it. So just protect y'all's brains as much as y'all can.
Oh my gosh, even riding bicycles, right? Or skateboards, like you want to be cool and not have to put on your helmet. And I don't think I've ever heard of anyone, you know, getting concussions from an incident with that. But to what you just said about protecting your brain, like when you need to, then you really need to.
Yeah, and part of the issue, like part of the unreported, is because a lot of these hits will not be great enough for you to be like, oh, I can't see. You know, like some people will fall and they're like, oh, I got a little headache. But they're
Yeah.
not saying like, oh, I can't see, I can't think. And then if that keeps happening over and over and over again, then next thing you know, you might have the same amount of effects as someone who plays football, because it's really going unreported and you're not realizing that you got a concussion. And another common type of concussion, you're in a car crash and like people say whiplash, but that whiplash is actually their brain shaking in their skull and it's like undermined. So they're just like, literally everyone has probably experienced either, if not a concussion, it's called subconcussive, which is like almost there. But if you keep experiencing that, you have these effects that are listed. So yes, it's crazy. And so, you know, everyone's talking about CTE with the football players, but we also, as everyday people, need to make sure that we're doing what we can do for ourselves.
That is a great place to end. And I was even gonna say, like, the CTE and football aspect is just a whole nother rabbit hole, I feel like, as far as the topic. But I think that you provided first of all, valedictorian. That is incredible. What you shared with those watching, as far as your STEM journey and your path to neuroscience and being an athlete. So for those watching and who are into sports and into STEM, like, look at Kendall. You can do it. You can be that person.
It's possible, everyone. Please, we need more of us.
I want to thank you all for watching and tuning in for our last Teen Science Cafe of August. I definitely want to encourage you. There will be a survey that you will receive. I'm putting the link in the comments and the chat box, but please take a minute to fill out that survey. As well as we have our STEM in the City for August this Saturday. And we are going to be talking about ecology and urban gardens and the variables that make healthy produce, as well as the variables that you should be aware of as far as pollution when you're gardening in urban areas. And so we're very excited for that workshop, and we hope that you will also sign up for that. I'll be dropping the link in the chat box.
And thank you so much, Kendall, for making time. It was definitely an interesting journey, learning about your journey, learning about different types of concussions. Then I was listening to my friends. Some of my friends like, I think some of my friends may have had a concussion. Like, and when I was growing up, they're like, keep playing, just take some Tylenol, right? So I am glad that you are doing this research um, to protect us, but also us thinking the different ways that we can have a concussion, just car accident, like all of these things that you never think that it's just exclusive to athletes, right? Like, we're fine, we won't have any brain damage or concussion because we're just chilling. But playing basketball on the court, getting on an accident, falling off your bike, falling off your skateboard, like, pretty much just wear your helmet. Is that the advice? Whatever we do, just wear the helmet.
Yeah, that's all we can do right now. We're trying to figure out better ways because the helmet's definitely not the best, but it's all we have.
Well, thank you so much of giving up your time. Thank you, everyone, for tuning in. And those that you will watch it on YouTube, thank you for catching us on YouTube. We hope you enjoyed the cafe and hope you learned a lot about neuroscience, and that if you like sports and STEM, you don't have to choose, right? You can be a scholar athlete that majors in STEM and successfully graduates, right? Because I know a lot of athletes, right? They push them to easy majors, right? Mm-hmm. And you're like, how are they gonna get a job if they don't get into professional sports? And so remember that if you like sports and you like STEM, Kendall is a great example of follow your passion for both.
Thank you.
Thank you so much. Well, good night, everyone. Thank you so much for tuning in, and we'll see you at our next event on Saturday and our next cafe in 2 weeks, Carlin.
Yes.
Okay. And do not forget to complete the survey, because that allows us to continue to get funding to bring you more cafes, continue to be safe, wash your hands, wear your mask, and social distance. Have a great evening, everyone. Bye.
Bye.